Hello everyone. In this video, we will build a simple OSPF setup. It will be an OSPF setup for single area, and we will add default route originate to that OSPF setup. So the setup we have is as the following. First of all, we have these two routers that run OSPF in the same area. So area 0 we have is actually going over these two routers. So we have single area, which is area 0, between these two routers, OSPF area 0. Now we have an ISP which is somehow connected to the internet. So we need to have a default route from router 1 pointing to the ISP. And from the other side, we need to have a static route in the ISP pointing to router 1 for the subnet 10.0.0.0/8. Now the challenge or the thing we need to configure is we want to make sure that this router 1, is sending this default route to OSPF area 0. Let's see the steps in more details. So these are the IP addresses for different interfaces in this setup. The setup or the lab goes through 3 stages. First of all, we need to build a network and configure basic device settings like IP addresses and basic security. We need to configure and verify single area OSPF version 2 between these two routers. And as you know, version 2 is for IPv4, version 3 is mainly for IPv6. And in part 3, we will configure the ISP, we will configure the default route, the static route, and we will originate or we will propagate the default route into OSPF area. So let's configure the steps one by one. To build the setup, we will have one router, ISR 4331, and the name for this router should be student ID, then R1. I will keep student ID as XXX, but typically it should be the student ID. Then we need to add another router, also ISR, and the router name should be R2. Now, there are some cases where the routers can be connected directly to each other, but in many cases they will have a switch between them. Let's add the ISP router, and then we will add the switch and the interfaces. So this router is ISP1. Now let's add the switch between the two routers. The switch is just a small switch, layer 2 switch, and it is not a major part of this setup. I'll just keep it as a switch. Now we will connect the links gig 000 to gig 001, and here gig 000 will be connected to Fast Ethernet 01, and Fast Ethernet 02 will be connected to gig 000. Now, in the switch, the interfaces are enabled by default. In the router, interfaces are disabled by default. We need to enable them. Now, we will enable them and configure the IP addresses one by one. Let's start from R1. Go to the CLI. No. Enable. Now, to show you the value of the command no IP domain lookup, just see here. If I try to type any command here, the router will try to resolve it using the domain server. So this is sometimes waste of time. That's why in the assignment you will see me asking for disabling IP domain lookup, because once we disable it, the router will not try to resolve any word or any unknown command, which takes a lot of time and wastes time. So in the basic configuration, we need to configure the enable secret. We need to configure we need to disable the IP domain lookup. We need to configure the host name. We need to create banner. And also, we need to save the configuration. This is the starting point. Then we need to configure the IP addresses and the list of the settings, including OSPF. So now I'm still waiting for this translation to be completed, which takes time. And that's why, let's see how to disable this. We don't want this to happen, and that's why we disable IP domain lookup. Conf t, first of all, host name. We need to configure the host name. It is not enough to configure it here. This is just a label. It needs to be configured here. Then enable secret plus service password encryption, no IP domain lookup, then we configure the banner message of the day. So banner authorized users only. Now we save the configuration, and this is the starting point. So run. Now we repeat the same steps in all the other routers. I will not show it here, I will do it later, but the same commands should be added to the 3 routers and even the switch. Now we configure the IP addresses. Interface. Giga 000 IP address 10.1.0.1 255.255.255.0, and in the router I need to enable the port, so no shutdown. Then interface Giga 001 IP address 192.168.0.1 255.255.255.0, no shutdown. And interface loopback 1 IP address 10.255.0.1 255.255.255.0. Now to verify, we use the command show IP interface brief. We make sure that the gig 00 is up. Gig 001 is down because I forgot to enable it. So conf t interface gig 001 no shutdown, and then write mem. Now as you can see, this interface is up with the switch because the interfaces in the switch are up by default, but this interface is down because we did not enable the interface in the ISP, and this interface is down because we did not enable this interface. Now we repeat the same steps on both routers and even the switch. Let's do the other router, router 2. The same command. The router name is ISR. The student number, then R2. Now we configure the interfaces. Before the interfaces, we need to configure the enable secret. We need also to configure or to enable the password encryption. We need also to configure the message of the day. And it is the same authorized access only. We need to enable no IP domain lookup. And then configure the IP addresses on the interfaces. As per the table, we start by interface gig 000, IP address 10.1.0.2, 255.255.255.0, and for sure we need to do no shut. Then interface loopback 1, IP address 10.255.1.1, 255.255.255.0. Let's verify. Show IP interface brief, and the interfaces that get IP addresses are all up. To verify, let's ping the interface on router 1, 10.1.0.1, and we can ping it. Now write name. As you can see, once I no shut interface gig 000, it became up and it is green now. The last step is to configure the ISP, and still we have the switch also, but let's configure the ISP first. No, we configure the host name. ISP 1. Then we need to configure the enable secret plus no IP domain lookup, service password encryption, and also message of the day. Now we need to configure the IP addresses. We have only one IP address on interface giga 000, IP address 192.168.0.2, 255.255.255.0, and for sure we need to no shut. And once I enter the command no shut, the interface became up and it's green now. Now we should be able to ping the interface on this side. So ping 10 or 192, sorry, 192.168.0.1, and we can ping it, which means all good. Now we know that this link or this segment is 192.168.0, and this subnet, the customer subnet, is 10.0.0.0. So here we have 192.168.0 pointing to the ISP and 10 pointing to the internal network. Now the first part is completed and we have the IP addresses configured. Now we need to enable OSPF within the area 0, within the two routers. But before that, we need to configure the switch just to make sure that we have some security on the switch also. So for the switch, first of all, we need to configure the host name. There is no host name; it is just switch 0. Then we need to configure the management VLAN. Typically, it is not VLAN 1, but for our configuration, just to make it simple, we will configure it in VLAN 1. 10.1.0.10, and the subnet mask. If we try show IP interface now, we can see that VLAN 1 is down because it's shut down. We need to no shut layer 3 interfaces, including the interface VLAN. So interface VLAN 1 no shut. Let's verify now. Show IP interface brief, and as you can see, the interface is up. We write mem, we try to ping addresses in the same subnet. Now typically we need to configure default gateway in the switch, so it is always a good idea to configure IP default gateway or IP static route 0000/0 pointing to the gateway. In our case, this is the gateway because it is the router that's connected to the internet, to the ISP. So the default gateway is 10.1.0.1, and we verified that we can ping that router or that interface, which means we can access our gateway. Exit and write mem. Now the IP addresses are configured. We are ready to start configuring the OSPF routing between these routers. OSPF will not be enabled on the switch. The switch is layer 2. We need to enable OSPF only here and here. I'll start by router 1. Conf T router OSPF, and the OSPF process ID is 1. Then we need to configure the router ID. Router ID will be 1.1.1.1 in our case. Now to enable OSPF on the interfaces, we can add network command here. Network command here can use the wild mask or the quadrant 0. But in my case, I prefer to configure the OSPF under the interfaces, which is more common nowadays, more recent. So I'll go to the interfaces one by one and enable OSPF. So I'll start by interface big 000. Then we enable OSPF. We need to specify the process ID, which is 1 in our case, and then the area ID. And again, area ID is 0. As you can see, I use the help, the question mark, which gives me all the options available. Sometimes you don't remember the details of the command, the options, the variables. So it is always good to use the question mark to know exactly what are the options you have. So in my case, the OSPF process ID is 1 and the area is 0. So this way I enabled OSPF on this interface. Now this router will start sending hello messages over this interface because it is not passive, but there is no one responding because OSPF is not enabled on this interface yet. So let's see what is the behavior. Now I need to enable it also over the loopback. And the same command, I use the arrows to go back to the same command, and this way I enabled OSPF on that command also. Now let's see what is the state. Let me write mem, which means save running configuration to startup configuration. Instead of typing save running configuration to startup configuration, it is enough to say write memory or write mem. Now, if we try show IP OSPF interface, let's make it brief to make it easy to read. We have OSPF enabled on two interfaces, gig 000 and loopback. For both of them, the area is 0, and one of them is designated router already because it is the only router with OSPF enabled. The other one is wait. It is actually a loopback, and the subnet will be broadcasted as /32. Now for the other router, I don't want the OSPF to broadcast /32. I wanted to broadcast the exact network as it is, and that's why I will use point-to-point on R2. Now on R1, if we see the neighbors, we have no neighbors. Why is that? Because OSPF is not enabled on the other side. The loopback has no neighbors, and this interface has no neighbors for sure because the OSPF is not enabled on the other side. Now let's enable OSPF on the other router and see how it goes. No need to enable OSPF on the switch. The switch is layer 2, so it has nothing to do with OSPF. We need to enable OSPF on this router also. Same thing, we go to the interfaces. First of all, we go to gig 000. Now the enable password that you configured already. Then conft, which is configure terminal. First of all, we need to enable router OSPF and the OSPF process ID, which is 1. And here we need to configure the router ID to be 2.2.2.2. Then we go to the interfaces one by one. And from here we enable IP OSPF, the process ID, which is 1, the area, which is 0. We repeat the same for loopback. And we enable the OSPF. And also, we want it to be point-to-point. Now, as you can see here from this message, we have full neighborship between these two routers. This one is the DR, this one is the DR other, or the BDR actually. We will see now. So let's exit, and write mem. If we see show IP OSPF interface brief, as you can see, OSPF is enabled on these two interfaces in area 0, and on this interface it is BDR because the other side is the DR, because it was up before. This one was enabled before, and once the DR is elected, it will stay the DR unless we reload the router or restart OSPF process. And for the loopback, it is point-to-point, so the subnet will be broadcasted as it is, as we will see. Now, if we try show IP OSPF neighbors, you can see we have one neighbor, which is 1.1.2.1, which is this router. It is full. It is the DR, the other side is the DR, and we are, or this router is the BDR, and it is working. Now, if we try show IP OSPF neighbor, or let's say show IP route, sorry. we don't have any OSPF subnet yet. This is why I show IP OSPF neighbor. We have one neighbor, and that neighbor should be broadcasting the loopback. Let's verify why this neighbor is not broadcasting the loopback. If we try here the same command, show IP route, we can see that the loopback is broadcasted as a full subnet. This is because we added the command show IP OSPF point-to-point or IP OSPF network point-to-point, which makes this subnet as a full subnet. Without this command, OSPF will be enabled on the loopback, but it will not really broadcast the subnet. So to broadcast the subnet, we need to add the command point-to-point to make the subnet broadcasted in the OSPF process. Now part 2 is completed, and now we need to configure part 3 of this exercise, which is mainly to configure the ISP. So we did this part 1, we did already. Assign the class, encrypt, the banner, we saved. Now for the OSPF, we configured the router ID, we configured the interface as, or the loopback as point-to-point for one router, and we enabled OSPF in all interfaces. In the final part, we configure static routing. We configure default route in R1 pointing to the ISP, and we configure static route in ISP for the subnet 10.0.0.0/8 pointing to R1. To advertise the default route into OSPF, we need to use the command default information originate, which we will see now. And also, because ISP1 does not have OSPF enabled, there is no need to send hello messages over gig 0001 in router 1, and that's why we need to configure it as passive. Let's go over the configuration commands. First of all, we will go to R1 and we will configure default route. IP route 0.0.0.0.0.0, and next hop is 192.168, which is the IP address of this interface. And if you go to the table again, it was 192.168.0.2. Now we have this default route pointing to ISP in router 1, and also we want to make sure that we are not sending any hello messages over this interface. We want this interface to be passive. So we go to router OSPF process and we configure the passive interface. Passive interface gig 001. This way we will not send hello messages, OSPF hello messages, and we will not try to establish any OSPF neighborship over this interface. Now we need also, under OSPF process, to configure default information originate to broadcast or propagate or announce this static route, this default route, into OSPF process. Without this command, the default route will not be broadcasted or announced by default in OSPF process. Now that's all from R1. Right, Mim. Now, as with any static routing, we need to configure it from both sides. So in the ISP, we need to configure a static route also. Conf IP route 10.0.0.0 255.0.0.0, and the next hop will be this interface. So we are telling this router, if you have any destination IP address to 10, send it to this router will take care. So the interface IP address for gig 001 in R1 is, as per the table, 192.168.0.1. We need to save, so exit and write in. That's all. We configured static routing, we enabled default information originate, and we configured gig 0001 as passive. Let's see the result. In ISP1, we don't have any OSPF. We have only static route pointing to router 1 gig 0001 for the 10.0.0/8. Now in router 1, if we try show IP route, we can see that we do have OSPF coming for the loopback. We have static route, and the rest are all either connected or local. Now if you go to router 2 and we try this one with the same command, show IP route, you can see we are not receiving the OSPF. For some reason we are not receiving the OSPF subnets from this router. We should receive the loopback, the loopback and the default route. Show IP OSPF neighbor. So we have this neighbor as full, and from the other side, show IP OSPF neighbor. Let's see the configuration. And we have default information originate. Let's verify this again. Default information originate, and we have that command. Let's try to restart OSPF process, or maybe we can shut the interface. So this is area 0, and here. Now it works. Looks like something was wrong in the interface. And now we can see the loopback, which is broadcasted as /32 because we don't have OSPF network type point-to-point here. And we are receiving the default route coming from OSPF process. That's all for this lab. Thank you for your time, and I hope it was informative to you. Thank you, and see you in the next video.